Okay, so let's see what's up with this negative versus. I'm going to guess that since most of our tests passed and only one of them failed, or one of those lines failed in the rotation test, that I just forgot to drop a negative inside of the tests. If we made an error in here, we'd see a lot more problems in here. In fact, actually, because we have, let me first point out, we did several versions of testing here for the rotation function, and only one of them had an issue. So I'm going to guess that one of these has an issue instead of this code over here having an issue. That's a good, nice logic thinking there, a debugging trip you can eliminate very quickly. Well, the problem should be over there, not here, because we have a lot of tests. Let me just demonstrate. I'm going to put a negative here, which is not correct. Control F5, build this, run this, and you see we still fail, but then now we're getting lots more errors. Alright, so had we gotten something like this, I think, oh, I probably made an error over here instead because it seems like there's a common theme. Okay, well, let me take that negative off. Build, run, just do a sanity check here, make sure we're where I think we should be. Yeah, we're back there. Sorry, I should bring this on screen so you can see it. Yeah, we're back to where we were at. Get this off the screen. Actually, you know what? We should use that screen to see where the problem is. It says in matrix 2D test.cpp, very good, line 41. So let's go look at line 41. Control G, go to 41. This is line 41. Oh, you see what we forgot to do? We forgot to put our negative here on the sign. So there we go. That's the upper right hand value of the matrix. So that problem is gone. Now we need to handle this, these values. So this is, if you think about it, we're dealing with, I've said this in several videos before, but I'll say it again. Computers think in ones and zeros. And when we store floating point values using ones and zeros, we have to come up with some clever ways to do it. And we have to use the floating point standard, which I talk about at length in the floating point videos. So go ahead and check those out if you're really interested in this. But long story short, this is close enough to zero. This is good enough for me to feel like, yeah, that's right. That's right. But let's just see here, lines 28 and 29, Control G, 28, 29. So right here, so our rotate didn't return a perfect zero. The signs, actually, let's see, these are the, let's see, this is cosine, sine, sine. So the sine function, the CMath sine function, is not returning a perfect zero. But it's close enough. I'm happy with it. So we need to do something similar to what we did in the clock test, where I said, it's close enough. It's really, I know there's going to be some issues. And the reason with the clock, if you think about when we were testing the clock, we were dealing with time in the processor. And so we kind of said a threshold, I think, of 0.01, which is actually pretty high, but it was close enough for timing and for government work. Here we're dealing with floating point values. It's almost there. And the expect float equals, though, is 2. If you remember, we're using this function so that we can test two floats that are probably equal, but expect float equals will take into account minor errors. But the error was so much with the sine and cosine that it was expect float equals still considered it not equal. In fact, with 0, it's expecting, you can represent 0 perfectly with a floating point type. So expect float equals is going to flag anything that's not 0 and say, hey, that is definitely not close enough. So we need our own utility function to say, hey, it's close enough. And we probably should have done that when we built the clock test. If you look here, remember we had this this threshold saying, it's close enough, it's good enough for government work. So let's build the logic once and then reuse it. Okay, that's hopefully something you learned in like your first or second programming class, is to reusability is a good thing. And I think for now, since we're only going to use it in the engine tester, we'll build this and put it in the engine tester. If it turns out we end up needing the logic a lot in our sandbox game or in our engine, we can refactor it out to the engine. But for now, I'm going to maintain as minimal scope as possible. I don't want to pollute the engine project with code that it doesn't necessarily need. If it turns out I find out later I'll need it, then I'll move it in. But I won't proactively try to throw in all the junk that I could possibly think it needs. I'm just going to, as needed, we'll do this. So let's go here and add a new item. Let's do a header file. We'll call it helper functions. Click add, and we'll pound if and def tester helper functions. Oops, H, Control L, Control V, V, pound define. pound end if, and this is just going to be simple little utility. So inline bool close enough, float left, float right, float threshold, and we'll default that to some really small number, but we'll use our own discretion to decide maybe 0.001. Maybe we end up tweaking this as we go. We could go and look at the floating point standards and figure out something that should be close enough, but that's testing. I think we're good. This is going to be easy. We're going to return the absolute. We need CMath in here. CMath. Return the absolute value of left minus right. So take the distance between those two floats, and if that is less than the threshold, then those two floats are close enough for government work. Okay, I hope that makes sense. If I have this big long number line, and I got a number, say here is on our number line, here's 2, and here's a 3, and I've got a number here, and I've got a number just right there. If the distance between those two is less than the threshold, we're good. Why the absolute value? Well, if I take a value of this and this value, and I subtract these two, if I subtract this value, this point on the number line, from this point on the number line, let's say this is a 2.3 and this is a 2.7. Well, let's go this way. 2.7 minus 2.3, that'll give, that one's not going to give you a 2, it's going to give you a 0.4. But if it turns out that I swap these inputs, and I really don't know which input's coming in first, so I say 2.3 minus 2.7, that's going to give us a -4. Well, or a -0.4. Well, that's less than threshold, because threshold is a positive value, but yet 0.4, that's definitely not close enough for us. So I don't want negative numbers always saying they're equal. So that's why we take the absolute value. We just say, well, let's make it positive. And 0.4, that's way past our threshold. But if we're right here, like 0.0001 or something, or 0.001, then we'll say that's good enough. Okay, so that's the logic there. We've made this. Well, it'd be good to commit it, but let's get our code working first. So let's go over here to matrix 2D tests. Where do I want to do this? Let's do it right here. Pound include helper functions. And did I say? Yeah, that should be good. Now, which ones were failing again? Let's look. Oh yeah, the signs. The signs. So 29, 30, 34, and 37. So let's go to 29, 30, then 30. Is this line 30? 30. That's 34 there. Oops, I just closed it. Where's my 34. Let's run this again. I can't remember. You probably do. 34 and 37. So 34 and 30. So that's 34. Then 37 is right here. So again, just bring those values up. -4 for those cosines and the sines. Yep, we're going to say that's close enough. So expect, excuse me, I'm going to write these numbers down. Bring this on 29. I'll tell you what, if you're not making videos, but you just need something to jot on your screen real quick, this Ink2Go program, I use it for this a lot too. So let's go to 29. Oh, we're already there. And instead of saying float equals, we're going to say expect true. We're going to say close enough. I should put that in a namespace probably, but left, right, and we'll rely on our default threshold for now. Let's do that again here. So expect true, close enough, that and that. Okay, and then 34. Expect true, close enough, and 37. Right here, expect true, Close enough. These two. Okay. Let's see. Our threshold might still be a little too tight. Let's run this, see what happens. Yep, our threshold is probably still too tight. Oh, I should have used the number that was on the screen. Do you remember the number we had before on the screen? It said the actual value. In fact, if we get here, let's look at close enough here. F12. I'm gonna just put a breakpoint here. Run this. So let's see, like 8.7 times 10 to the negative 8. So let's use blue. 8.7 times 10 to the negative 8. Well, 10 to the negative 8 means we're going to move the decimal place left 8 spots. So here's 1. The 8 is the 1, 2, 3, 4, 5, 6, 7, 8. An extremely small number, close enough to 0 for what I care about here. So our threshold really needs to be something similar to this. Let's put a 1 here. Let's put a 1 right here. I'm feeling in my gut, so to say, that 1 right here. I mean, this number is greater than this number, and yet this number is still extremely small, so I'm happy with that as our threshold. We'll put that as our default threshold for now. 0, 0, 0, 3, 4, 6 zeros. So 1, 2, 3, 4, 5, 6 zeros. So let's eliminate 2 of these. Shift F5 to stop debugging. Let's build this, run this. And all greens. Nice. Very nice. Okay, so our matrix test passed. There's a lot of other little things I noticed as we were getting along down the way here this far in our testing. You're probably anxious to get to the game. Again, you can skip all these testing videos if you want and start working on the game stuff. But there's actually some pro C++ things I want to point out I think would be worthwhile looking at and sharing with you.